Good morning, Trig. We're going to cover lesson 42. And 42.A simply covers conic sections. I believe we touched on a couple of these in Algebra 2, but we didn't cover them very thorough. So I've listed the four conic sections, and that's really all that 42.A goes over, and it goes over how they're formed, which is the intersection of a cone and a plane. But there's no really work to do in 42.A. 42.B is going to slowly start to get us to cover these conic sections. And so they begin with circles. Now, circles means that the locus of all points are equidistant from the center. Now, this is pretty obvious because what we know about a circle, and if we're going to graph it, let's just say we graph it, the center, a circle has a radius. And a radius means that I am equidistant all the way around from my center. So that's what makes a circle versus, let's say, an oval like the ellipse. Now that's kind of a sloppy one, but each point should be equidistant. So you have two parts, right? You have the part in the middle is my center, and then half any measurement from here to the center is my radius. And it should be the same all the way around. Now, in our equation, our center is represented by h, k, and our radius is represented by r. So standard form of our equation is the following. Parentheses, x minus h squared plus y minus k squared equals our radius squared. Again, h and k is our center, r represents our radius. General form is when we have everything on the same side. So we have no parentheses. So this would be x squared plus y squared plus r squared equals 0. Note that there are no parentheses when it's in general form. So you do need this piece of information so that when a test or homework asks you for a particular form, you have it. So we're going to actually practice a couple. So number 1. And I'm going to give actually the same directions for all of the following. So find the standard form of an equation . Okay, so they want us to find the standard form of the equation of a circle and then write in general form. Now, I don't like to write, because this is math, I don't like to write directions over and over and over. So we're going to do that for every example that we do together. So number 1, my center of my circle is at -3, 3, and the radius is 4. So let's start with standard form. I have h and k, right? Here's h, here's k, this is r, right? We already labeled it r. So my standard form would be x minus a -3 squared plus y minus 3 squared equals 4 squared. Now I'm going to simplify that, so that's x plus 3 squared plus y minus 3 squared equals 16. So here it is in standard form. Now I'm going to write it in general form. So I first need to distribute my parentheses. And notice general form, I have everything on the same side, so I'm going to have to move my radius. So I need to distribute parentheses. So these first two give me x squared plus 6x plus 9. These two give me y squared minus 6y plus 9, and I have minus 16 equals 0. Now, I'm going to list it in the order above. So we first begin with our squared terms. They're not alike, but we write them next to each other. X squared plus y squared. Now I'm going to do my x and y terms, so plus 6x minus 6y. And the only thing we can combine, right, is 9 plus 9 minus 16. So 9 plus 9 minus 16, that's 18 minus 16 is positive 2 equals 0. So that is general form. So I have standard and general. Okay. Moving on to the next one. So if my center is at 4, 0, and my radius is at 6. Okay, so let's plug it into standard form. I would have x minus 4 squared plus y minus 0 squared equals 6 squared. So let's simplify that. That would be x minus 4 squared plus y squared equals 36. Now let's work on our general form. So x minus 4 times x minus 4 plus y squared, and I would have to move the 36 because general form equals 0. So the product of these gives me x squared minus 8x plus 16 plus y squared minus 36 equals 0. So general form, list your squared terms together, so x squared plus y squared. I do not have a y term, so minus 8x, but I can combine these. So 16 minus 36 gives me negative 20 equals 0. Okay. I'm going to do one more just so we're familiar that you could end up with problems with radicals in them. And so I'm going to do one with you in that case. So last one, and then we'll move on to part C. So let's say now the center of our circle is at 1, comma, negative root 2, and our radius is 2. All right, so let's go ahead and write this in standard form. And you know what, I should have labeled the last one with general. Okay, just so you get an idea of each one. So standard form would be x minus 1 squared plus y minus a negative root 2 squared equals 2 squared. Now you can leave the 2 in that form, 2 squared. It does leave that if they just want standard form. But because I'm converting this to general, I am going to simplify each piece. So I have x minus 1 squared plus y plus root 2 squared equals 4. All right, now I'm going to go ahead and put this in general form. So we're going to need to distribute x minus 1 times x minus 1 plus y plus root 2 times y plus root 2. And I'm going to subtract 4, so this equals 0. So the products of this is x squared minus 2x plus 1. Right, because you have negative 1x minus 1x, that gives you negative 2x. The product of these two would be y squared. Now, if you can't see it right away, then I would have root 2y plus root 2y plus 2, and then minus 4. So I'm going to combine like terms, and I'm going to list this in proper order. So remember, we list our squared terms first, then negative 2x. These are like terms, and there are 2 of them, so I get 2 root 2y. And then I can combine my constants. So 1 plus 2 minus 4 gives me negative 1 equals 0. And so that would be in general form. All right, we are going to move on to the next part of this lesson, which is 42.C. And I'm going to actually do it on graph paper because we are going to be graphing. But this is looking at constants in exponential functions. And the purpose of this section is writing complicated exponential functions in a familiar form. So exponential equations, I would have y equals, and I would have a times, well, technically, yeah, a times b to the x minus h plus k. That is what they're referring to when they say exponential. Now remember, h is left and right. It's a horizontal shift. K is up and down. So I'm going to do a few with you. We are going to rewrite the equation and we are going to graph the function. And so that is what I'm going to write at the top. That is the directions for all of the following problems. We are going to rewrite the equation and then we're going to graph it. All right, so number 1. Y equals 4 to the negative x. Now, without a calculator, this transformation it can be kind of complicated. And so we're going to rewrite this. Now, I'm using my exponential properties. I'm going to rewrite this to be 4 to the negative 1 times x because I know that we multiply exponents. So I'm rewriting this. This can then be written as 4 to the negative 1 is really just 1/4 to the x. Now that is super easy to graph. So I'm going to do this. I'm only going to use a few points. So just in a little table, -2, -1, 0, 1, 2. 1/4 to the negative second would be 16 because you would flip it over. 1/4 to the negative first would be 4. Anything to the 0th power is 1. This would be 1/4 or 0.25. And this would be 1/16, which I don't have memorized. 1/16, 1 divided by 16 is 0.06. So my graph, I'm only going to graph these 3. -1, 4, 0, 1, 0.25. And so here is my graph. That is an exponential decay because my base is less than 1. And next one, we are going to graph y equals 0.5 to the 3x. So the first thing I'm going to do is I like to write, if I have decimals, I'm going to write it in fraction form. Now I'm going to use the same thing. Now this is really hard because this means that x has been compressed. And that's really hard to graph if you're not going to rely heavily on a table. So to rewrite this, I'm going to use the same knowledge from last time. This is 1/2 to the 3rd to the x. Now that would give me 1/2 to the 3rd is 1/2 times 1/2 times 1/2, which equals 1/8 to the x. That is super simple to graph. Again, we'll just use a few points. -1, 0, and 1. So 1/8 to the negative first would give us 8. 1/8 to the 0th power gives us 1. 1/2 to the first power gives us 1/8, which equals, I think it's like 0.125. And so those are the only 3 points I'm going to graph, and I'm even going to change my scale, right? Because none of us like, here's 1, -1, here's 2, 4, 6, 8. And so when I graph this, I've got -1, 8, 0, 1, and then 0.125. It almost looks identical to the last one because I changed my scale. Now, if you're too lazy to transform this, I guess you could just use the original equation and build a table. Guys, there's no reason you can't answer these problems. With the fact that you have Desmos, the internet, and calculators, you should be able to do these problems. Next one, y equals 3 to the negative 2x plus 4. So again, I want to put this in the simplest form possible. So I'm going to rewrite this to be 3, and I'm going to factor out a -2 because I realize that these have 2 in common, and it's always good to take out the negative that's in front of x. So -2 would leave me with x minus 2, and this is much simpler. So now I have y equals 3 to the negative second would be 1/9, and x minus 2, that right there means a shift to the left 2 units. And so that's exactly what I'm going to do. I'm first going to build a table. I'm going to build a table based on I'm going to build a table based on 1/9 to the x. And then I'm going to shift my points. So -1, 0, 1. This would be 9, 0, 1/9, which is, in our calculator, 0.11. Then I will shift my points 2 units to the left. All right, so 2, 4, 6, 8, sure. And I know I'm moving to the left. And I'll go ahead and label this one. All right, so I'm going to draw the original in pencil. This would be 2, 4, 6, 8. So with a pencil, my original graph should be at -1, 9. Whoops, this should be 0, 1, right? Anything to the 0th power is 1. So then the next point's here and 0.11, right? But we're shifting it 2 units to the left. 2 units to the left, 2 units to the left, and here is my graph. It's very steep. And there is my graph. And that is how you would take care of those types of problems. For homework, we are going to skip numbers 2 through 4, 18, 20, 21, 28, and 29. Thank you.